Foundations of Amateur Radio. If you've been around the hobby in the past decade, you may have come across the invention of a software-defined radio, or SDR. You might even own one, and if you've looked into how it works, read the explanation that essentially describes it as a traditional radio where all the components are implemented in software. To me, that's like explaining how a radio works by waving your hands and saying, "Here is magic." How it actually works is something altogether more interesting and thought-provoking. If you think of sound, like my voice, coming from a speaker, you can imagine putting a voltmeter on the speaker terminals and measuring every second what the voltage is. As my voice gets louder, you might measure a large voltage. As I take a breath, it will be smaller. You could chart the different measurements and show a waveform that would represent the loud and soft parts of what I'm saying. The faster you measure, the more accurate the picture represents my voice. For comparison, a CD player does this measurement 44,000 times per second. If you were to play back those sound measurements at the same rate into a speaker, you'd end up with my voice. And that's actually more or less what's happening if you're listening to this podcast. Yes, for the purists, there's more to it, but not relevant at this point. Similarly, if you were to hook up a voltmeter to an antenna and take measurements, you'd end up with a chart that represented the signal strength that your antenna is receiving. And the faster you measured, the better the representation. What it exactly represents, I'll come to in a moment. The waveform that represents my voice is actually a very complex signal. In much the same way as a piece of music is made up of different notes, played in sequence and in concert with each other, my voice is also made up of separate frequencies, played together to form the words that you hear. If you were to measure those separate frequencies and draw a waveform for each, you'd see how every one contributes a little to the overall effect. And if you were to add them all together, you'd have my voice again. In the same way, the waveform that represents an antenna signal is made up of all the separate frequencies that go into the overall signal. You might be surprised to learn that an antenna is actually hearing all frequencies at the same time. Some better than others, but typically all of the RF spectrum at any given time. Your radio is also essentially hearing all frequencies. When you tune to a local station on 720 kHz, you're actually telling your radio to ignore all the stuff that isn't 720 kHz and to only process that small bit of what it's hearing. The selectivity of a radio is the measurement that represents how good your radio is at being deaf to all the things you don't want to hear. To help that filtering, a traditional radio and antenna works by pre-selecting part of the RF spectrum. When you press the AM button on your car radio, you're selecting which chunk to listen to. Press the FM button on the same car radio, you'll select another chunk. On an amateur radio, you select by choosing the 80-meter band, the 40-meter band, etc. Similarly, your antenna is predisposed to hearing a particular chunk better than others, but that doesn't make it immune to signals across the entire range. You may have heard described that a software-defined radio hears all frequencies at the same time. Essentially, it's a voltmeter connected to your antenna, spitting out measurements as fast as it can for processing by a computer. The waveform that comes from those antenna voltage measurements represents all of the RF spectrum, and it's just the beginning of what you can do next. In the same way that my voice is made up of lots of different parts, all played together, the RF spectrum is made up of the local broadcast stations, the local TV stations, mobile phones, garage remotes, Roy on the 7130DXnet, this podcast on your local repeater, all at the same time, all played together, to make the waveform that represents the measurements you make at the base of an antenna. I'm going to ignore for a moment how exactly we extract the various bits, or how we decode an FM or SSB signal using software. It involves some math. Instead, we can look at something that is easier to explain. Unlike with a traditional radio, which has to work hard to filter out undesirable information, a software-defined radio can filter out information by just deleting those measurements you're not interested in. Yes, there is more to it, much more, but that's the beginnings of how an SDR works. If you'd like to get in touch, please do. cq@vk6flab.com. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.